Meet Maya. She's standing at the school lunch counter, and today she gets to choose her meal and her drink. She's wondering, what are all the possible combinations she could end up with? And what are the chances she gets her favorite? That's exactly what we're going to figure out today, using one of the coolest tools in math, the tree diagram. Let's go. First things first, what exactly is a compound event? A compound event is when two or more separate events happen together. Each event on its own has its own set of possible outcomes. When we combine them, we get a whole list of possible combinations. Think of Maya's lunch. She picks a food and a drink. That's two events happening together. That makes it a compound event. Simple, right? Here's where the magic happens. A tree diagram is like a visual map that shows every possible outcome of a compound event. You start with a trunk, the first event, and draw branches for each outcome. Then from each branch, you draw more branches for the second event. Every complete path from start to end represents one possible outcome. Count all the paths, and you've got your sample space. That's every possible result. Let's build Maya's lunch tree diagram together. Maya has 3 food choices: pizza, burger, or salad. And she has 2 drink choices: water or juice. So we draw 3 branches for the food, and then from each food branch, we draw 2 more branches for the drinks. That gives us 3 times 2, which equals 6 total possible lunch combinations. Here's a great shortcut. Just multiply the number of outcomes from each event. Now for the big payoff. Once your tree diagram is drawn, calculating probability is a breeze. You use this formula. Probability equals the number of favorable outcomes divided by the total number of outcomes. The tree diagram already shows you all the outcomes, so you just count the ones you want on top, put the total on the bottom, and simplify if you can. Maya's tree diagram just made probability so much easier. Let's solve Maya's first question. What's the probability she gets pizza and juice? Start by looking at the tree diagram. We have 6 total outcomes. That's our denominator. Now, how many of those paths end at pizza with juice? Just 1. Pizza goes to water or juice. Only the juice path counts. So we put 1 over 6. The probability that Maya gets pizza and juice is 1 out of 6. Not very likely, but it could happen. Now Maya wonders, what are the chances she gets water no matter what food she picks? Look back at our tree diagram. Total outcomes, still 6. Now let's count how many paths include water. Pizza with water, that's 1. Burger with water, that's 2. Salad with water, that's 3. So 3 out of 6 outcomes include water. We write that as 3 over 6, and then we simplify. 3 divided by 3 is 1. 6 divided by 3 is 2. So the probability is 1/2. A 50-50 shot. Here's the cool thing about tree diagrams. They work for 3 events too. You just keep adding more branches. Imagine flipping a coin, rolling a 6-sided die, and spinning a spinner with 3 colors. The coin gives 2 branches, the die gives 6 branches from each coin result, and the spinner adds 3 more. 2 times 6 times 3 gives us 36 total outcomes. It gets big fast, but the tree keeps it organized. Maya's getting the hang of this now. Let's try a classic. What's the probability of getting 2 heads when you flip 2 coins? First, build the tree. Coin 1 gives heads or tails, 2 branches. From each, coin 2 also gives heads or tails, 2 more branches each. Total outcomes, 2 times 2 equals 4. Our 4 outcomes are heads, 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 tails, tails, heads, and tails, tails. We want heads, heads. That's just 1 outcome out of 4. So the probability of flipping 2 heads is 1 out of 4, or 25. Now let's make it trickier. What's the probability of getting at least 1 tail when flipping 2 coins? We already have our 4 outcomes: heads, 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 tails, tails, heads, and tails, tails. At least 1 tail means 1 tail or 2 tails, anything except 2 heads. Let's count. Heads, tails, yes, 1 tail. Tails, heads, yes, 1 tail. Tails, tails, yes, 2 tails. That's 3 outcomes with at least 1 tail. So the probability is 3 out of 4. Maya's solving these like a pro now. Let's try one more. You spin a spinner with 3 equal sections, red, blue, and green. Then flip a coin. First, how many total outcomes? 3 spinner outcomes times 2 coin outcomes equals 6 total outcomes. Let's list the tree. Red heads, red tails, blue heads, blue tails, green heads, green tails. Now, what's the probability of landing on red and flipping heads? Only one path does that, red heads. So the probability is 1 out of 6. Tree diagrams make this so clear. Before we wrap up, let's talk tips for drawing great tree diagrams. Number 1, always list every single outcome for each event. Don't skip any. Number 2, draw your branches neatly and in order so it's easy to read. Number 3, use multiplication to double-check your total. Multiply all the branch counts together. And number 4, label every endpoint so you can clearly see the full combination. Follow these tips and your tree diagrams will always be spot on. Look how far you've come. Remember when Maya was staring at her lunch tray wondering about all her choices? Now she and you can map out every possible outcome with a tree diagram and calculate the exact probability in seconds. Compound events, sample spaces, favorable outcomes, you've got the whole toolkit. Keep practicing with coins, spinners, and whatever you can think of. You're a probability pro now. Go show